So good morning everybody. So today we want to discuss the topic on river training structures. So yesterday we have seen the case study as well as the some examples in this river training works, and those examples are elaborated by the one of the professors that is scientist from the CWPRS Pune. So as per the information about the river training works, so the river training works is nothing but you have to guide the river of the flow by constructing a structure. So the river training actually implies that various measures adopted on a river to direct the flow and guide the flow. So to direct the flow and guiding the flow is very important aspect you have to be considered in this river training structure. So direction of the flow is going to be takes place by constructing a structure we call as the river training structures and guiding the river flow into the constructed path for controlling the scoring and the erosion actions. So this procedure and these aspects of this river you have to be called as the training of the river. So to train and regulate the river bed or to increase the lower water depth. So purposes of this river training structure is nothing but to stabilize the channel flow along the certain alignment or along this edge of the river. Means none of the flow should have the problem with the currents, with the formation of vortices, and reach must be the stable reach. Second purpose is that the importance of the river is mostly depends upon its length, width, velocity, and seasonality. So why it is very much important? So whatever the behavior of the river, it totally depends upon the types of the river. Either the river is flashy river, either the river is the virgin type of the river, or either it is a perennial or non-perennial type of the river. So that it depends mostly on its length. What would be the H length, width of the river, velocity of the flow, and you need to be consider the season. Either river is flowing in summer season, winter season, or uh, during the time of this monsoon now year. So some rivers are short, like that is the most of the rivers flowing in the western directions in South India, called as the Konkan River, like the name of that river, Surya River, Tansa River, Savitri, and the Cat, etc. These are the names of the Konkan rivers. And what is the nature of that river? Those rivers are flowing in the western direction in the South India. So the utility is lesser than this river in northern India, like this Ganga, Yamuna, Brahmaputra. All these are the major river basins which are too long now here and perennial type of the river. What are the objectives of the river training? Yesterday we have seen few of the objectives on a different way. But as per your the university patterns and for attempting the exam, you need to understand the objectives of the river training. So the first objective is to provide the safe passage to the flood discharge without overflowing to the banks for the protection of cultivated and inhabited areas. So the safe discharge, that means the safe discharge is very much important. Because of that, whenever you have seen the various classification of the flow, actually this is the open channel type of the flow, and always we are thinking for the turbulent flow in case of the river. But the turbulent flow is there, but it must not be creating the problem on the banks of the river. So without creating that is overflowing to the bank, also protect the bank of this cultivated and inhabited area. Second purpose is there to prevent outflanking of a work. So there is no outflanking of work like the bridges, weirs or any aqueduct. Then to protect the river banks from heavy erosion, that is the major problem, and to improve the alignment of this river by stabilizing the river channel. The next objective for this river training is to transport the bed and suspended sediment. Once the river has carrying the sediment load, then definitely the sediment load must be required to remove it from the path of the river. So important is that is the transportation of the base and the suspended sediment load with a maximum efficiencies. Means transportation must be there, but the amount of the silt is deposited in the banks of the river, immediately it can be drained out from there. Because otherwise what will happen, that is the overflow of the water is to be take place, and there will be the chances to create the flood now. So to deflect the river away from the bank, which may be the attacking. Then second part is a very important part about the classification. Always the question shall be asked in examination. Classify the river training work. So there are the three categories of the river training. First one is the high water training. So what do you mean by the high water training, or it is called as the training for the discharge. It is also called as the training for the discharge. So in this high water training, dispose of the flood water, surplus water, and to provide the protection of those flood water against the any type of the damage due to such type of the flooding. That means the training for the discharge, you call as a training for the discharge. So in this type of this training, that is the disposal of this flood water, also to protect the banks of the river due to this heavy water, heavy floods, and you have to control those damages due to such type of this flooding damage. Second category is their low water training. So what about the low water training? So particularly this training is also utilized for the navigational purposes. So in this low water training, you have to maintain the depth of the waters as per the requirement of the navigational channel. So in this low water training, to provide the sufficient depth of the waters for the inland navigation during the low water season, that means during the summer, for the non-perennial rivers, mainly in the southern India. So that you have to call that the low water training is nothing but training for the depth measure. And third category of this river training work is nothing but the mean water training. So what do you mean by the mean water training? It's a smooth disposal of the bait and suspended sediment loads, and to maintain the shape of the channel, that means the training of the sediment. So especially this classification is made to control the sediment as well to prevent the sediment and to extract the sediment from the river water. Then coming towards the methods of the river training, how many methods are there? So the methods of the river training, that is first one is the marginal type of the embankment. So I want to show you the photographs, actual photographs about this marginal embankment. So they are the earthen construction, just like the earthen dam. It is similar to the earthen dam, which built to continue the flood water within the cross section available between these embankments. For example, river flow is there, and this is the direction of the flow. You have to construct the embankment along the bank of the river so that the water should be guided smoothly without creating any problem. So because of this embankment, what is the purpose behind this? So is there any problem of the scoring erosion actions, or is there any aggrading type of this river? Then in this case you need to provide the embankments. This is similar to the earthen dam, and launching apron is also again provided towards the river, that means in the transverse direction. So these are the earthen constructions within the cross section available between this embankment, but because of this constricted path, the water can be flows into the reach, and finally it goes to the downstream direction. So what are the effects of these marginal embankments on the flooded river? So first of all, no doubt, that is utilized for increasing the velocity of the flood water. How it is increased? Because of that, the constriction of this path, what will happen? This path becomes the narrow, and due to this narrow shape, the velocity is going to be increased again. So therefore, the increase the velocity of the flow, you have to utilize this, and the water can be flowing in the downstream directions because of this increased velocity. Second effect we have to be observed with this marginal embankment is to increase the surface elevation during the flood now. So the elevation is goes on increasing because of this construction, but it is helpful to you. Second thing is that to increase the velocity of the discharge at all the downstream points. Once the velocity goes on increases, then definitely as per the velocity, the effect is occurred on the downstream directions. Also, it is helpful to increase the water surface slope of the stream of this upstream leveed portion. This is the part that is a type of structure, bunds, or this is a leveed type of this river training work. Then let us see the guide bunds, second part, or called the bunds. Guide bunds is nothing but that is these are the earthen embankments to channelize the flood water to the river. In India, such type of the bunds were designed first by the Bale, is the inventor, so known as the Bale's bund. As per his name, the name of that bund is the Bale bund. See, this is the section of the bund. You look out this. This is the top portion, and this is the bottom portion. This is the top portion. So need to be constructed these bunds along the length of the channel, and the cross section if you have to observe. Suppose this is a cross section AA. You have to be observed. This portion is nothing but this is a launching apron. It is towards the river. Then this is sloping portions where the pitching of the stone is going to be carried out, and this is the construction part where we have to utilize the earthen material or the available material, and this is now the stone is also utilized, that means the reserve stone. And through these stones, this is the top level, it is provided at the top level, and we have to maintain the slopes now here. This is on river side and this is on the bank side. Maintain the slope and constructing it now. Similarly, we have to carry out the section BB. Suppose for example, section BB is here. If you look out this, then section B, this is the top width. You see here, this is the top width, and this is the sloping portion on both sides. It is on the river side, it is on the bank side, and the entire slope is going to be provided. So generally slope is provided for the guide bank is in range of this 2s to 1 or the 1s to 2, and the launching apron can be provided where the water can be drained out easily now. So this is the way to provide the guide bunds, or you call as the guide banks now. Then third type of the structure called as the groins or the spurs. It is a structure that is constructed transverse to the river flow. The earlier construction were constructed along the flow, but this groins or the spurs is directly constructed in the transverse directions along the flow now here. That is the in transverse direction. So it is a structure constructed transverse to the river flow. It extends from the bank into the river. What are the functions of these groins or the spurs? So the first function is to protect the river bank by keeping the flow away from it. Second part is to construct a wide channel for making the river navigable. Then to train the river, third function, along the desired course by attracting, deflecting or reflecting type of the flow in the river. Suppose it depends upon the directions where you can be provide this groin in the river or across this river. So according to this angle, if it is a straight way, then you have to be called as either it is attracting or the deflecting. If this angle is deviated, then definitely it is attracting. If angle is deviated in the upstream side, again the obstruction. So the such type of these courses where we have to guide the flow according to the need and the purposes. Suppose the barrages are to be constructed over there, and to divert the flow of the river towards the barrage, at that time such type of the structures are very much useful. That is now the groins or the spurs now here. So to create the slack flow with the objective of the silting of the area in the vicinity. Then classification of these growens. There are the sub-classification according to the methods and the materials. So first one is the impermeable growens. If we have to construct those growens with the help of the impermeable material, so don't allow the flow of the water through them. Side slopes is ranging in between 2:1 to the 3:1. This is the launching apron is also provided on both the ends, and it is going to be placed constructed with the help of the sand and the gravel now here. So the almost it is impermeable growens, and water cannot be seeps into this sand and the gravel. It allows the percolation, but immediately through this launching apron it will be goes out now here. So the such structures you have to be called as the impermeable type of the growens now here. Then second one is the permeable groin. This allows a restricted flow of the water through them. Directly allow the flow of the water into this groin. Then according to the height of the groins, this classification is there. Non-submerged groins and submerged groins. If it lies above or below the surface of the river, functions are like that. That is a attracting type of the groin. Already I told you. If the angle is deviated in the downstream direction, then this is attracting where the flow is diverted and it goes into the downstream direction, but there is the formation of the portholes or the score holes. This is a single attracting type of the groin. A groin which points out downstream tends to attack the river flow towards the bank on which it has been provided. Then repelling, already I told you, if this angle, this is axis of the groin, is deviated in the upstream direction, then you called as the repelling type of the groin, and it tends to repel the river flow away from the bank. So still pockets are generated on its upstream side, and the flow is going to be takes place, but there will be the chances of the scoring, particularly near to this repelling type of the groin. This is one of the drawbacks. Then deflecting type of the groin is nothing but they are either perpendicular. Here they are either perpendicular to the bank or the pointing slightly upstream have the shorter lane, only small deviations, and you have to look out the flow is going to be takes place in the downstream direction of the flow is like that, and you have to be observed only the small pocket holes due to this deflecting. And third category, that is fourth one, is the sedimenting type of the grains. That is the river carry the considerable amount of the sediments. Then special, actually I want to tell you here, special, that is the Dennis T headed groins you have to observe here. And these types of these groins are reported at the Okla headwaters on Yamuna river in Delhi in 1880. Later on it is going to be changed now here, but the shape of this groin is T shaped. Shape of this groin is a T shape. It is invented by the Dennis, so that's why it is called as the Dennis T-headed groin. Then similarly, our one of the professor, that is he is my guru now here. Uh, he has invented the one of the groin, and the professor is from the Walchand College of Engineering, Chandigarh, Dr. Ranade sir, and he is now the retired professor, and he has invented a groin now here. So that's why it is called Dr. Ranade sir's groin. It is similar to the T-headed type of the groins now here. So the hockey head or the groin, these are provided just like this shape, hockey stick type. So are provided with a curved head, such as it looks like the hockey stick now. Then cutoff is very important part. If there is a chances and if the river meandering is going to be takes place, then there is need to reduce the length of this river flow. So why not you have to construct the cutoff trench. Cutoff trench is the channel is provided, and straight away the river water can be diverted into this cutoff area. So allowable river flowing along, because of that when the river is moving in this direction, that is in this zigzag manner, or if the course of the path is going to be changed at that time by provision of the cutoff, so need to again divert the flow from the river into the downstream direction. So such type of the structures we are going to be provided, that is a cutoff now. Already you are knowing this. So that is a bend's abundance, a particular bend and establishes its main flow along the straight and the shorter channel. So the ratio of this length of the bend to the chord is called the cutoff ratio. So this is the chord and this is the length. So the length to the chord ratio we call as the cutoff ratio. When it exceeds 1.5 to 2.3, the natural cutoff is going to be take place. Then pitched island, you know, if the water is also flowing into the river and there is need to provide the rotary type of the island here, then flow is going to be diverted in all the directions. So such type of the structure is called as the pitching island. See the structure here, this is the crest part and this is the slopy part. So we can provide the slope on all the sides like this. You have to be observed there. Then pitched island is nothing but it is a artificially constructed island in a river bed. It consists of the sand core which is protected by the stone pitching on all sides of this island and they work as a guide bank. Other methods we call as the bundling method. Better to go with the bamboo matting. See the layout plan of these bundles by providing inserting this bamboo into the soils into the bank of the river and only the flow is going to be diverted now. So the such structures again you see here the bundles are to be provided at the different location so that the flow can be diverted into this navigable channel now. It is applied to low water flow in a single channel for maintaining the required depth for island navigational purposes. So the bundles is going to be provided. Only the bamboos are inserted into the sand of the river and the flow is only trying to divert it. This is only particularly utilized for maintaining the depth of the water into the river.